here we go, 36. So here, what I'm going to do is look to see what's happening here. I've got a -2 in the parentheses, so this is going to tell me it's in the parentheses with the x. So this is going to be a shift backwards of what I think, 2 units to the right. So what I'm going to do is I'm going to graph just the basic y equals ln x function. Now, remember, the value of E is approximately equal to 2.718. When I'm doing it here in my t-chart, I'm just going to use 2.7 for E since I'm not using a calculator. So again, for the natural log, remember it's always a base E. So if you want to rewrite it and show that it's got a little e there, I'm going to now use my Bay trick and turn this into exponential. So it's going to become e to the y power equals x. And now this is what I'm going to do in my t-chart. So x and y. And again, when you're doing this, you're going to plug in values for y, not for x. I'm going to plug in -1, 0, and 1. So when I plug in a -1 for y, remember a negative exponent makes it a fraction, so 1 over e. And again, remember e is equal to approximately 2.7. So if I divide this, you could also think of it's about 1/3. So this is actually when I divide just 2.7 and not the E button, it's about 0.37. Again, my graph goes by ones, so just know that you're putting it in between 0 and 1. Because again, we're not going to graph precisely 0.37. Then e to the 0 power, anything to the 0 power equals 1. And then e to the first, we're really just doing 2.7 to the first power, which is 2.7. So now I'm going to go ahead and graph these 3 points and get my basic graph of y equals ln x graphed. So here, almost to the 3, and then here. And again, it's going to skim along this vertical asymptote. Skim along. So this is just the graph of y equals ln x. Now what I need to do is shift the 3 points and my vertical asymptote 2 units to the right. So remember, the only time we shift the asymptote is when it's a left and a right shift. So I'm going to move the asymptote over 2 units to the right. And then I'm going to take these 3 ordered pairs and also shift them 2 units. Maybe a little bit more here, and then here. And then it skims along, and here is your graph of y equals natural log of x minus 2. Now, in the video, for the next example, I did not actually do this one, but I'm going to go ahead and do it, and I'm going to show you the one I did as well. Yes?
Why is it the base 10? Isn't an example 27 that the base was 10?
Okay. So whenever it's the word log and there's not a little number here, that's where it's assumed to be a base 10. But when it's the natural log is always has a base e. So if there's, and they're never going to write the e, you just have to assume that it's there. Now, in the video, let me just go ahead and do it on this same thing here. So in the video, the function that I actually graphed was y equals the natural log of negative x. We learned yesterday that you can never take the log of a negative number. So really what we need to do is factor out like the negative sign, and then this is going to indicate that it's a reflection. So I could have graphed these original points, and then I can reflect them. So remember, the original was in black. So if I wanted to do this graph, which is what I did in the video, I could just take these 3 order pairs that I did in black, and I could reflect them across the y-axis. I don't know if you can see, yeah, I guess you can see the green. So then 1, 2, 3, and then over here. And this would be the graph of what I did in the video. Now, I actually did a T-chart using just this equation instead of factoring out the -1. So what I actually did in the video is I did ln of, and I left it like this. But when I went to put this in exponential form, I set it up this way. So then when I did my T-chart, -1, 0, and 1, e to the -1 power equals -x. This becomes 1 over e, but I never want to have a negative variable, so I had to divide both sides by -1. So this was -1 over e equals x. So this turned out to be -0.37. When I plug in the 0, e to the 0 equals -x. 1 equals -x. Divide by -1. And that's how I got the order pair -1 in the video. And then here, e to the first equals -x. E to the first is 2.7 equals -x. Divide -2.7 equals x. And notice these were the order pairs that I just graphed in green.
How do we know if it reflects across the y-axis or the x-axis?
So whenever the negative sign is here in front of the x, it's going to be a reflect across y. If it were negative ln x, then that would be reflect across x. So that,
Okay.
yes.
Let's say we were reflecting the, say, log of x minus 2 across the y. Is the asymptote get reflected too?
Yes. And that's, yes, that's what we're going to see in the next one. So actually, all right, so for this one, when we shifted it, we can see that the domain now, because the new asymptote is now at x equals, let me go ahead and fill this in. Our new asymptote is now at x equals 2. Oh, you can't see. Thank you. So this is number 36, once it connects here. Okay, so for number 36, we shifted it 2 units to the right, so also our asymptote shifted. So our new asymptote is now here at this blue line, and it's at x equals 2. So when we shift our asymptote, our domain also shifts. So now our domain is now from 2 to infinity. Or actually, yeah, from 2 to infinity. Now, we can also find our x-intercept, and we can sort of see it on the graph here. If you knew that the x-intercept here was at 1, 0, you move it 2 units, it's going to be at 3, 0. But let's go ahead and do the math behind it, because this is what I'm going to want to see is the math behind it. So we could turn this into y equals ln x minus 2. Now, what we can do here is, remember, this is also equivalent to log base e of x minus 2 equals y. And I can go ahead and plug in the 0.
Wait, but didn't you say that the base for log is going to be 10, not e?
No, not when it's natural log. Natural log is always e. Now, all right, let's just leave it as ln. But just know that these are equivalent. So let's just leave it ln. And again, you assume it to be an e. I'm going to plug in 0 for y. So now I'm going to turn it into bay. So e to the 0 power equals x minus 2. E to the 0 power is 1. Add 2. 3 equals x. So my x-intercept is at the order pair 3, 0. Because remember, you plugged in 0 for y. So that's how you find the x-intercept on that one, and the domain and the asymptote. Let me show you on number 37. All right, so when we're graphing the log functions, whether it's log or natural log, so let's just say it's log x equals y, or ln x equals y. Whenever we're graphing any of these, what you're going to do is turn it into exponential, make your t-chart, and then graph the basic function, and then apply shifts. So when you have something like this, y equals log of x, and let's say it's plus 2, or let's say, just to show you that you could switch the word, and instead of writing the word log, you could put ln, and let's say it was a minus. Whenever there's something being added or subtracted, not in a parentheses, this is going to be the shift vertically. So it's like the number you see. So this one would be up 2, but this one would be down 2. Then when you have it in a parentheses, so let's say we have log parentheses x minus 2. And just to show you that you could switch the word, let's say it's x plus 2. When it's in the parentheses, it's backwards of what you would think. So you'd think you'd be moving it left, but this would be right shift 2 units. And then this one would be left 2 units. When you have a negative sign, remember that's going to indicate your reflections. So y equals negative log x. This would indicate, this negative sign indicates that this is a reflection across the x-axis. If it's over here in front of this, let's say it's like that, then this would be across the y-axis. And that's sort of what we're going to do today with the last example. Pretty good. So this is just a little summary of the different shifts. You could also make it go up faster if there's something being multiplied, but these are the basic shifts you're dealing with. So let's try number 36. I did not do this one in the video. I'm going to do it right now with you. So at first glance, you're thinking, oh, it's a reflection, and then it's going to be a shift to the left. But what we need to do is we don't want to take the log of a negative number. So I'm going to change this, and I'm going to factor out a negative 1, and then it becomes x minus 2. So now this is going to tell me that I'm going to shift it right 2 units, and then this negative sign is going to indicate the reflection across y. So what I'm going to do is I'm going to do the basic y equals ln x graph, and then I'm going to reflect it and shift it. And I will also shift my asymptote and reflect it. So let's go ahead and do the t-chart. So again, I already did the t-chart because again, remember you're doing e to the y equals x. So over here, negative 1, and that gave me the point 37. 0 gives me 1, 1 gives me 2.7. So let me graph these original, y equals ln x. My vertical asymptote is right here. It's going to skim along the asymptote. Now, we can do this in steps. So I could reflect it. So if I reflect it first, I'll put my point here, here, and here. And now I'm going to shift my asymptote 2 units to the right. So now my new asymptote is over here. And then I take the 3 points and I shift them back to the right 2 units. So here and to here, and I don't want it on highlight, so here, here, and here. And here would be your shifted graph. So that's the final y equals ln 2 minus x. No, it's hard to see. Yes.
Why is it 0.37?
Because I'm only using 2.7 instead of the e button. So what I did was 1 divided by 2.7. And when I do that, I get, let's see, 1 divided by 2.7. And on my calculator, I get 0.37037. Because e to the negative 1. So what I did was I'm putting in e to the negative 1, which really means 1 over e. And then that's 1 over 2.7. So that is it for the graphing of the natural log. Any questions?
Can you do an example where it reflects across the x?
So for 37, we can see that the asymptote has shifted, but notice my final graph was in green. So now, this time my domain is going to be all numbers that are less than 2, because it's everything on this side. So it's going to be from negative infinity to 2. That's the domain. And then the asymptote is at x equals 2. And again, I could plug in the 0 in order to get the new x-intercept. So let's take the original y equals ln 2 minus x. Again, I'm going to put the y equals over here so I can do my Bay trick. I'm plugging in a 0 for y. Again, remember to assume the little e there. So I'm going to be doing e to the 0 power equals 2 minus x. 1 equals 2 minus x. Subtract 2. Negative 1 equals negative x. Divide by negative 1. X equals 1. Your x-intercept is at the order pair 1, 0. So when you do this on the quiz, I'm going to want to see all this work.